we can rewrite this again when we separate our variables. This is what we're doing. We're using our rules of differentiation. We're using our rules of differential equations. This would become dy over y minus 60 equals k dt. That we separated, we integrate. So we're going to throw in some integral signs here. We're going to integrate. On this one, now if you look carefully, it's that rule of integrating logs. The derivative of my denominator is my numerator. I can simply integrate this as the ln of the absolute value of y minus 60. And over here, this becomes kt plus c. Right? Now, because y's got to be greater than 60, we can get rid of my absolute value signs. We can write this as ln of y minus 60 equals kt plus c. All right? Equals, well, we can write it like this, c e to the kt. We've gotten pretty comfortable with doing that. Which can then be as y equals 60 plus c e to the kt. All right, we want to get that y alone. All right, now we're going to be using y equals 100 when t equals 0. We're going to put these into what we know, and we get 100 equals 60 plus c e k to the 0, which gives us c equal to 40. You're going to have to subtract over this, of course, to get your 40, okay? All right, so when c equals 40. So because y equals 90 when t equals 10, we get to look at something different now. We get to look at 90 equals 60 plus 40. That is our c that we just found out, times e to the k times 10. We wind up getting 30 equals 40 e to the 10k, or k equals 1/10 ln of 3/4, which is approximately negative 0.0288877 when you do it on your calculator. All right, now we have all the information we need. We've got our c, we've got our k. So what we can now do is we can give our general form, our general equation, what we can use to find out other t's. We get y equals 60 plus 40 e to the negative 0.02877. Tack on that t. All right, so this is our general form. What we want to know is we want to know what it is when y equals 80 degrees. All right? So, let's find out. We get 80 equals 60 plus 40 e to the negative 0.02877t. Now we need to solve for that t. We want to know how long this took. We get 20 equals 40 e to negative 0.02877t, or 1/2 equals e to negative 0.02877t. Using natural logs, get the ln of 1/2 equals negative 0.02877t. Or in this case, t is approximately 24.09 minutes. So it took approximately 24.09 minutes to cool at 80 degrees. It's going to take about 14.09 more minutes from the original for the object to cool to 80 degrees. Okay? That's the end of these notes. Now, what I want you to be doing for the remainder of the period is we have a guest speaker coming in on Wednesday. His name sorry, I can't talk today. Upper level and lower level math classes. He was one of my college as well as level classes in general. The type of work you'll have to be putting in, the time that will be spent, what the courses are actually like, what will be expected of you as a student. So what you'll be doing for the remainder of, well, this period and probably is I want you each to come up with at least, which means that number or more than, 3 questions for Dr. Emmons about college level classes, college level math classes, and so on. At least 3, if not more, okay? I will be looking at these before he comes in, so this is an assignment that I will be collecting and making notes on. This is important for all of you. I think it's going to help you with actually going off to college, since many of you will be doing so very shortly. If you finish this, then you may complete your weekly or work on any other type of calculus work you need to get done. You're working on calculus stuff, Stephen Buell. All right, so I will see you tomorrow. We'll be going over any questions that you may have, and I will see you then. Thank you.